Okay, here we go. This is finite math, section 2.4. You'll notice I have a 2 up there, and that's telling me this is my second attempt. The first one didn't come out the way I wanted to, so this is a little revised edition. Things that you should know. I gave you an introduction into matrix inverses. So just to kind of, just relate it to something you know. In algebra, we would have simple problems such as, let's say, 2x equals 10, where you're supposed to solve for x. Okay, so what we would do, we would divide both sides by 2. So take 2 into 2x gives you x, and 2 into 10 gives you 5, so x equals 5. Okay, so that's really easy. Okay, so what if I said you could not use the concept of division? Well, that changes things a little bit. We would think divide. Well, instead of thinking divide, think in terms of multiplication. And then what we would do is multiply by the reciprocal of 2, which would be 1/2. And 1/2 is actually the multiplicative inverse of 2. I know you're still getting the same results. Here's what we're getting at. With matrices, you cannot divide. It's not defined. So we multiply by the inverse, and then that is what we call the inverse method. And that's what I'm going to show you here. So the first thing we need to do is be able to find inverses of matrices. Okay, well, okay, let's back up a second. First of all, we need to write these equations, these systems of equations, and write them in matrix form. So let's say that we have these two equations here. I've got negative 2x plus 4y equals 2. I've got negative 3x plus 7y equals 7. Okay, so just imagine the coefficients here. So I got negative 2, 4, negative 3, and 7. Just imagine that as a matrix. Okay, and a lot of times we'll just call that, let's say, matrix A. And then, then you have this is the coefficient matrix. Then you have a variable matrix, which in this case is x and y. Those are the two variables. So just imagine that as a times x. And then over here, we're going to get some sort of matrix we'll call B, which is really the two answers, 2 and 7. Now, take a look at this. Let me change pins. If I was actually multiplying this matrix times this one, I have 2 rows. Remember, you take the rows times the columns. You've only got one column here. So if I take the first row times this column, I'm going to have negative 2x plus 4y equals 2. That's the same thing I had over here. And likewise, if I take the second row, so it's negative 3 times x plus 7 times y, that will be equal to 7. That's the second equation. So I went from here to here. I wrote it from a system of equations to a matrix equation, but then I showed you how to go from a matrix equation back to this. The whole point is this is the same thing as that. It's just another way of writing it. Okay, so like I said up here, A is going to be right here. That's what you call your coefficient matrix. Your variable matrix is xy, and B would be what I would call your answer matrix, the 2 and the 7. Okay, so here's the whole concept. If you go back up here, when I was saying 2x equals 10, which means x equals 5, I multiply both sides by 1/2 to get my answer. In terms of matrices, this was A times x equals B, so that's what I wrote down here. So if I want to find x, I'm going to take the inverse, just like when that was a 2, I multiplied by 1/2. If I did it up here, those are going to drop out, so I didn't write it. So the variable matrix x would be equal to the inverse times whatever B is. And this is what we call the inverse. That's what I wrote down here. It's a to the negative 1 power. It's not really the negative 1, but that's the way they designate the inverse. Okay, so back to what I was saying a minute ago. Now we got to be able to find the inverse. So I've got some examples here. So let's say I have this matrix, which I just, put in A, B, C, and D. Not numbers, just letters. The inverse of this, if you'll notice, look down here, see the A and the D? See how they switch places? So now D's up here and A's down there. B, you took the opposite. C, you took the opposite. And then you got to multiply by this 1 over D. D actually stands for the determinant, but you don't need to know that. And to find D, D is equal to AD minus BC. So basically you're taking A times D and you're subtracting B times C. You're kind of a cross multiply type thing. Okay, so let's look at an example. So let's say I have matrix A here, and I want to find the inverse of it. Okay, first of all, we're going to find D. So we're going to take negative 2 times 7. A is negative 2, D is 7. I wrote each of those here. So D would be equal to negative 2 times 7 minus negative 3 times 4. And when you simplify all of that, you end up with negative 2, because that's going to be negative 14. The two negatives there make a plus, so it's negative 14 plus 12 is negative 2. Okay, then it says interchange A and D. Here's A, there's D. We're going to they're all they're going to do is switch places. So the 7 is now up here, and the negative 2 is down here. So they switch positions. B and C, you take the opposites. So this is 4, so down here I'm going to put negative 4. Here's negative 3, that's the value of C, so the opposite of that is going to be positive 3. So that's where those numbers come from. Now let's put it all together. We want to multiply by 1 over D. So that's where the 1 over, and when you look back up here, D was negative 2. So I'm going to put negative 2 here. And then this is what I did with the matrix. I switched A and D, so the 7's up here, the negative 2 is here. This became negative 4, and this became 3. Thought I had something wrong there. Okay, and then let's go one more step. The actual inverse would be to take this negative 1/2 times everything inside. That's scalar multiplication. So negative 1/2 times 7, that's going to be negative 7/2. Negative 1/2 times negative 4 is positive 2. Negative 1/2 times 3 is negative 3/2. And negative 1/2 times negative 2 is positive 1. So my inverse will be equal to negative 7/2. I know you can't read that very well. 2, negative 3/2, and 1. Okay. Now, before we go on, I've got a couple other examples. This is not in your outline, but I put a few examples together. I want to find out what the inverse is of each of these. So we know we're going to take 1 over. We got to find D. D is going to be 2 times 1 minus 5 times 6. So that tells us down here we're going to put negative 28. Not your typical number, but we'll make it work. A and D is switched. So I had 2 here and 1 here. We're going to switch. We'll put 1 in that corner and 2 in that corner. B and C, you take the opposite. So if that was 6, this becomes negative 6. That was 5. This becomes negative 5. And then the last step, we're just going to take negative 1 over 28 times each of those. So negative 1 over 28 times 1 is negative 1 over 28. Negative 1 over 28 times negative 6. The negatives drop out. I got 6 over 28. In lowest terms, that's going to be 3 over 14. And yes, you always put them in lowest terms. Here you're going to have a negative times a negative, so it's going to be positive, and that's simply just going to be 5 over 28. And then when I take negative 1 over 28 times 2, it's going to be negative, and 2 over 28 in lowest terms would be 1 over 14. So that is actually the inverse of matrix A. We started with A, now we got the inverse. Okay, let's go to the next one here. So the first thing you're going to find is D. D is going to be 7 times 1, which is 7. 2 times 3, which is 6. So 7 minus 6 is equal to 1. So that means the inverse of B will be equal to 1 over 1. So that doesn't change anything. And then inside, you're going to switch the 7 and the 1. So 1 here, 7 there. And you take the opposite of the other two. So negative 2, negative 3. 1 over 1 is 1. So the inverse is simply going to be equal to 1, negative 3, negative 2, 7. Got one more here. Okay, so I got 6, 9, 5, 8. So D, the determinant, will be equal to 6 times 8 is 48. Minus 5 times 9 is 45. That's going to be 3. So my inverse of C would be equal to 1 over 3. And then inside, we're going to switch the 6 and the 8. So 8 comes here, 6 goes there. The opposite of 9 is negative 9, and the opposite of 5 is negative 5. So my inverse becomes, I'm going to take 1/3 times 8, that's 8 over 3. And then 1/3 times negative 9, negative 3. 1/3 times negative 5 is negative 5/3. And 1/3 times 6 is going to be 2, and that would be the inverse. Okay, so we did enough of those. You should have a pretty good idea of how to work these now. Okay, so now we're ready. We're going to put it all together. Okay, this is back. It's part of the outline. So, wait a second. I am missing a page. Thought I was missing a page. Hold on a second. I'm checking my notes here because there should be one problem that's not on here. It should be on your outline. Perhaps it's not. Come on. I had everything on my laptop here and it rebooted on me. So everything's got to come back up. Oh, for goodness sakes, I don't want that. I want this. Almost there. No, I don't have it. It's not my outline. Okay. Well, let's go to this one. What I wanted to do here is give you a problem. So we want to solve for X and Y. And I know you've already got several ways of doing it. I mean, you've got linear combination, which I'd probably do. You got substitution. You could graph them. You got the Y equals method. You could even use Gaussian elimination. Okay, but we're gonna use what they call the inverse method. So first thing we're going to do is we're going to write this as a matrix equation. So there's my coefficients, my coefficient matrix. Here's my variable matrix, X and Y. And then my answer matrix is 12 17. Okay, so this is like A times X equals some matrix B. So if I want to find the variables, all I have to do is figure out what the inverse of A is and then multiply it times B. So there's the inverse. This is the easy part. I got 12 and I got 17. So what is the inverse? Well, if we go back over here, I tried to do this. I'm going back to this page here I just finished. If you'll notice, matrix A on this page was 2, 6, 5, 1, which matches 2, 6, 5, 1 here. So I'm going to save the trouble of going through all of that. But here's my inverse. So I'm simply going to copy that over here. So I've got negative 1 over 28. I've got 3 over 14. I got 5 over 28. And I got negative 1 over 14. So to solve this, all I have to do is multiply those matrices together. So remember, you're going to take the row and the row, the two rows, take the rows, and you only got one column here. So x, remember this is xy, x will be equal to negative 1 over 28 times 12 plus, I can't read my writing, 3 over 14 times 17. So that's going to be, let's see, that's going to be negative, bear with me here a second. That's going to be, let's just call it negative 12 over 28. Keep it simple. Plus, this is going to be 51 over 14. 3 times 17 is 51. Let's get a common denominator. That's going to be negative 12 over 28. So if I made this 28, that's going to be 102. So negative 12 plus 102 is going to be 90 over 28. Seems like I've got something wrong again. So anyway, that'd be 45 over 14. Yeah, that's not what it's supposed to be. Let me check my work here. 2, 6, 5, 1, xy, 12 and 17. 3, 2, 3, 3, 5. Oh, I know what I did. To save us from going all the way back through, to get my answer to work out right, that should have been 18, which means this should have been 18, which means this would have been 18, and then this would have been 18. Now when I multiply, that would have been negative 18 over 28. This would have been negative 18 over 28. So negative 18 plus 102 would be 84. That would have been 84 over 28, and that is equal to 3. There you go. I knew I had a nice answer. Sorry about that. Okay, so that's x. Y, I'm going to take the second equation here, so that's 5 over 28 times 18 plus negative 1 over 14 times 17. 5 times 18 is 90. That's 90 over 28. Plus, actually it's a negative 17 over 14. Common denominator, let's call it 28. So I'm going to have 90. And over here, I'm going to double it. It becomes minus 34. So 90 minus 34 is 56 over 28. And that's going to be 2. So my answer is the point 3, 2. So again, once I found that inverse, I'm just simply multiplying a matrix times a matrix, which we did that in the last section. So it's this negative 1 over 28 times 18 plus 3 over 14 times 17. We did all that and we got an answer of 3. Then when you take the bottom row times this, that's 5 over 28 times 18. Negative 1 over 14 times 17 gives us this. When you simplify all that, that's 2. So you had x, you have y, and there's your answer, 3, 2. Okay, so the hard part is actually finding the inverse, and then you simply multiply, and you come up with the answer. And that's all there is to this section. I had another example of this, but I don't know what happened to it. So I'm going to call it quits there, and the next time you'll see me will be in section 2, 5.